People, people of the world, what is happening? Hey, I hope you're doing great. We are going to get back after it today. So 6-3, we get to learn, yes, our second algebraic method for solving systems. Call this little booger here elimination. Interesting. So yesterday was substitution. We substituted in a value, really an expression, from one system into the other, and then we solved it. Today, a little bit different, elimination. We are going to actually eliminate, yes, one of our variables, x or y, out of our equations. Sounds interesting. How are we going to eliminate stuff? I don't know, probably a little bit of multiplication, but here's what we got, guys. So again, here's our step, people. So if you're a step person, refer back to this a lot. But basically, guys, we have to write our system in standard form, right? We want them to be in standard form. So no longer do I want one of them solved for x or y. If one of them is, solve it with substitution. But when they're not solved for x or y, slope-intercept form, and they're in standard form, this is the method I want to look for, okay? And what we do is create opposite or the same coefficients in one of our variables. Kind of sounds weird. Then we're going to do some adding and subtracting, which you'll really enjoy. And then we'll have a super easy equation to solve, and we'll go from there, okay? All right, so here's what you guys need to remember. Okay, I want you to write this down. Same, subtract, okay? Okay, same, subtract. You'll hear me say this in class all the time. Opposite, add, okay? So there's kind of your reminder, and this refers to step 2, okay? Okay. All right. So anyway, so this looks familiar. We saw these yesterday. These are a system of equations. Here we go. Right now, normally we'd think, oh yeah, solve one of the equations for x or y. Again, probably wouldn't be a bad idea. We could solve this one because 6 and 18 are both multiples of 3. Wouldn't get any fractions there. That would be okay. However, we have a better way to solve these, right? And that is with elimination. Elimination, I want you to look at your 4 coefficients, right? -3, 4, 3, and 6, okay? We want to find the same or opposite coefficients in one of the variables, right? And we have them right here in our x's. I've got opposite coefficients. 3 and -3, gang, are opposites. 4 and -6 aren't anything, okay? But this right here is opposites. So step 1 is already really done for us. Congratulations. We move on to step 2, which is this right here. Same, subtract, opposite, add. So what are our coefficients? Well, again, they're opposites, so we are adding, right? So we are going to add these. We're going to add these 2 equations together, and like magic, our x variable will eliminate itself, right? Because watch this, guys. What's -3x plus 3x? Nothing goes away, okay? Watch your signs. 4y plus -6y is -2y. 12 plus 18, 30. Check this out. I already know what y is. Solve this equation for y. Divide by -2. Y equals -15. Wow, we got our first answer super quick there, didn't we? Okay, that's what happens with elimination. We get one of our answers pretty fast, right? Other one, we got to work for it a little bit more because now we're in standard form. One of our equations isn't already solved for a variable. But we know y is -15. You can use either equation, substitute it back in, okay? It really doesn't matter. I'll choose this top equation here. So -3x plus 4. Again, every time I see y, I replace with -15, okay? And now we just solve this equation for x, okay? We can do that. So this is -3x. 4 times -15 is going to be what? -60. And that equals 12. So then we're going to add 60 over there. -3x equals 72. Divide by -3. X equals negative. Oh, it's early, but I can still do this. That's 12, and that should make -24, I do believe. Okay? Bam, perfect. There's elimination. Again, this is best case scenario, guys. our coefficients are already the same or the opposite. Okay? All right. Remember, you just got to write this down and just remember this. Same subtract, opposite add. All right. Again, look at your coefficients, right? X coefficients, 3 and 2. That doesn't do me any good. Here's the ones that do, -5 and 5, right? Sweet. Go ahead. Same subtract, opposite add. So these, once again, are opposites. So we will add 3x plus 2x makes 5x. This goes away. This turns into 1 plus 9, which is 10. X apparently is the number 2. Okay? Once again, substitute 2 in for x in either of these equations. Just to be different, I'll choose this equation here. So this is 2x, or 2 times 2, plus 5y equals 9. Okay? Leave this to be 4. Right? We're going to move 4 to the other side with a little bit of subtraction. So we will subtract 9 minus 4, which is 5, and we get y equals 1. Bam. Perfect. Okay? Again, there's our 2 answers. Don't just stop here and give me 1. That doesn't do us any good. Oh, drat. That was going so well. Then they throw a word problem in here. Okay. 4 times one number minus 3 times another number is 12. 2 times the first number added to 3 times the second number is 6. Find the 2 numbers. Okay. We got 2 numbers, guys. If you want to call them x and y, that's fine. Right? You could say, hey, the first number is going to be x. The second number is going to be y. Okay? We're good with that. Got something in my eye. Still there, but we're gonna power through it, guys. All right, so 4 times one number going to look like this. Minus 3 times another number is 12. 4 times one number minus 3 times another number, right? That's how I know they're different. It says another in there, is 12, right? Second equation comes from the second sentence. 2 times the first number, right? Well, that x was the first, so 2 times the first number. Added to 3 times the second number is 6. Okay. Again, 4 and 2 aren't any good for me. -3 and 3 is where it's at. So those are my opposite coefficients. That's right, guys. You guessed it. Same subtract, opposite add. Okay. If we tried to subtract here and we subtracted correctly, nothing will eliminate itself, right? And then that should be a giveaway to us, right, that we have not done this correctly. Anyway, we have done it correctly because this will turn into 6x. This eliminates itself, and this turns into the number 18. Right? And then this turns into 3. So x is 3. Again, doesn't matter which equation we use, the first one or the second one. I would think most of us would pick the second one because we don't have any negatives in here. Okay? Everywhere we see an x, we replace it with 3 now. So 2 times 3 plus 3y equals 6. So this is going to be 6 plus 3y equals 6. Okay, don't freak out. Nothing going to happen here. We're going to subtract 6 turns into 0, and yes, y is allowed to be 0, guys. Sometimes we get this, we think we did something wrong. We haven't done anything wrong here. Y is just 0, okay? Don't be a hero. Y is 0. It doesn't even make any sense, but go with it. Okay. Hey, more word problems. You guys are excited for them, aren't you? I know you are. 4 times one number added to another number, just added to another number, is -10. 3 times the first minus the second number is -11. Find the numbers. Guys, why don't you pause this one, try to write it. Again, just use the same thing. Use x and y. Again, first number will say x, second number, or as they say, another number, which is, right, how they identify that there's a second variable in here. So go ahead, pause this, write it. I'm going to write it up here. Okay, hopefully you're back. Here we go, guys. 4 times one number, 4x, added to another number is -10. 3 times the first number minus the second number is -11. Okay. 4 and 3 are not opposite or the same coefficients. However, 1 and negative 1 are. Same, subtract, opposite, add. I wonder if we'll ever subtract. Give it a slide. All right, this will turn into 7x. My y's eliminate. Careful here, guys. Negative 10 plus negative 11. If you have to use your Kendrick calculator, make sure it's powered up and go for it. This is going to turn into negative 21. Okay? Easily solved. X is negative 3. Bam. Now, make a good choice here. We can, once again, choose either one. If you choose the bottom one, right, we replace, right, x with a number, we go over there, but then you got negative y, right, and then we still have an extra step in there. If I choose this one, as soon as I move that 4x over, then I'm done, okay? So I'm going to choose this one. So we're going to say 4x plus y equals negative 10. Again, we know x is the number negative 3. Sorry, I almost goofed that up. Negative 3. All right, so this is negative 12 plus y is 10. Right, we're going to add 12 over here, and hey, now we're done. Okay, nothing more to do. So a little bit easier. Again, it's just one less step. It wasn't going to take us but another 8 seconds, right, to take the opposite of that. Okay. Okay. Same, subtract, opposite, add. Come on. Uh-oh. Oh, no. Oh. Things were going so well for us, guys. Okay, hold on. We got to go adjust it back here. Okay. We're back. Almost. Here I am. All right. Again, check out your coefficients. 9, 1. Negative 2, negative 2. Aha. Same, subtract, opposite, add. What operation should we do here? Same. We have the same coefficient in our y's, negative 2. We subtract. And this is where I would think for most of us, we might need to slow down a bit, right? Because when we subtract, you've got to remember this sign here, and all things could happen. So 9x minus 1x is 8x. Negative 2y minus negative 2y, right? Double negative would turn to addition, okay? And that's why y eliminates itself. 30 minus 14, 16. Again, easily solved because we did some good arithmetic here. X is 2, all right? Go back to either equation. Smaller numbers probably here with this one. X minus 2. Oh, nope. All bad. We don't know what y is yet. Equals 14. Replace x with 2. So this is going to look just like this. All right, we're going to move that 2 to the other side. A little bit of subtraction. Divide by negative 2, y, negative 6. All right. So I know what a lot of you are thinking. You're thinking, man, this way is great. Let's just do this all the time. Well, yes, right? But remember, we're really only doing, as we'll find out, half of elimination, right? Not all of our systems will always have a coefficient, okay, where we have the same or we have opposites in it, okay? So unfortunately, it's not always going to be that way or that simple. Tomorrow, we're going to get into elimination part 2, we'll call it, okay? But for now, enjoy it, right? Nothing wrong with us having a stress-free day. Hardware store earned this much money from renting ladders and power tools last week, okay? The store charged 36 days for ladders and 85 days for power tools, okay? This week, the store charged 36 days for ladders and 70 days for power tools and earned a whopping $829. How much does the store charge per day for ladders and power tools? I don't know. Sure we do. We just got to write a system, guys. We're just going to write these last two. I'm not worried about again, you can solve them. They're going to have what might be bad numbers. But anyway, if we're not sure of our variables, read the last sentence. How much does the store charge per day for ladders and power tools? There's your two variables, ladders, power tools. Okay? So let's just call those L and P. Okay, for ladders and power tools. Great choice. So we know that they earned $956.50, right, from renting these two things. Apparently, they live in an area where people need ladders and power tools. All right. And they charged 36 days. Like, guys, when you go, you can rent a tool for half a day, a whole day, a week, right? Whatever it is. So they've tallied up all those days and half days and whatever, and they got 36 days worth of ladder rentals and 85 days for power tool rentals. Okay. Again, we don't know how much they charge per day. Is it $5? Is it $50? $20? I don't know. Okay. So 36 days of ladders is not a very good. We're gonna audible here, guys. We're gonna go D for ladders. Okay. Plus, right? However much we rent 85 power tools for, and we made $956.50 from renting those items. Okay. So there's the structure of the first one. You guys want to try to write the second one? If you do, pause it and go for it. Okay. Otherwise, it's 36 days for ladders. All right. And what do we got? 70 days for power tools. Right? And that's $829. Okay. All right. So there you go, guys. There's your system. Again, what do we have here? Right? We have matching coefficients in our ladder variable. Okay. So same subtract, opposite add, right? So we are going to subtract all of this. I mean, sure, I guess if you want to, we can subtract this. Just good practice. So obviously we eliminate here. 85 minus 70 just turns into 15. And 956.50 minus this is, it's too much, right? It's 30, it's 71 plus that 56.50, which it's just, guys, it's Friday morning, right? Not really for you, but for me. All right, so it's $127.50, right? So we can easily divide that by 15 and say, hey, apparently we rent a ladder for $8.50 a day, okay? If we want to figure out how much we rent power tools for, you guys know what to do. Take that $8.50, plop it into one of these equations, multiply it by 36, subtract it from that number, then divide by your coefficient, good to go, okay? We're not going to do that due to time constraints, but we will move on to the very last slide that we have. Ooh, good old fundraiser problems. These ones are a dime a dozen. All right, for a school fundraiser, Marcus and Anissa participate in a walkathon. We used to have a walkathon here at Faircrest. In the morning, Marcus walked 11 miles. Anissa walked 13. They raised that much money. Good job, guys. After lunch, Marcus walks another 14. Anissa walks another 13. And they raised that much money. How much did they raise per mile, right? So in other words, they're getting donations every mile they walk. Somebody says, yep, I'll give you $1 or I'll give you $5 or whatever it is. All right. So I'm just going to use their initials, their first initials for each person. So in the morning, Marcus walks 11 miles, so 11M, right? Plus Anissa's 13 miles. And they raised a total of $523.50. Okay. The afternoon equation form looks very similar. Marcus walks 14. Must have had a good lunch. She was really fired up, ready to go. He walked more. Anissa, all she could do was walk the same 13 miles. Good for her. And they raised $586.50. Okay? So, guys, I'll let you take it the rest of the way from here. Okay? So you go ahead and obviously our A variables are the same. They are the ones that we'll eliminate. So we're going to use subtraction, same subtract, opposite add. So anyway, so guys, there you go. There's elimination for you. As I walk too closely to the screen, you can't see me anymore. We are going to do part 2 of elimination. Again, this one will make things easier for tomorrow, whenever that might be, for day 2 of elimination. So finish this problem up, bookwork, quizzes, all that other good stuff, and I'm sure you guys are doing great. See you.